Lesson 10.3, Operations with Radical Expressions. Our essential question is, how do you add and subtract radicals? So we have three new vocab words. The first one says adding radicals, and then we have subtracting radicals, and then like radicands. Like radicands. It's kind of an odd word. Like radicands are similar to like terms. So they have the same radical part. So the same radical part. So kind of like when we worked with like terms and we said they had the same variable part. So the same radical part, like the same number under the square root. That's what you'll be seeing today. And that makes them like terms. So on the adding radicals, you notice that it says a times the square root of b plus c times the square root of b equals a plus c times the square root of b. So you add the numbers in front. As long as the square root part is the same, you add the numbers in front, the coefficient numbers, just like when we work with like terms. So for example, we could say like 3x plus 2x equals 5x. Now instead of x, it will be a square root of something. Like 3 times the square root of 2 plus 2 times the square root of 2 equals 5 times the square root of 2. So very similar to working with variables. Very similar. Subtracting, same thing. As long as the square root part is the same, the radical part is the same, you can subtract the numbers in front and keep that radical the same. So add numbers in front or subtract the numbers in front. And it doesn't change what's under the square root. So as long as they are like radicals, you can add or subtract them. Now, this first slide is going to be pretty easy compared to the rest. So 5 times the square root of 2 plus 3 times the square root of 2 minus 7 times the square root of 2. So you notice that they all have the square root of 2 as their radical part. So I can take the numbers in front and add or subtract them. So 5 plus 3 minus 7. 5 plus 3 is 8. Minus 7 is just 1. So it's 1 times the square root of 2. Or you might just see it written as the square root of 2. Because when you work with variables, if we had 8x minus 7x, you don't have to write the x with the 1 in front. You can write it just by itself. So you don't have to have the 1 in front of the x. Okay. Our next example, 8 times the square root of 3 minus 2 times the square root of 5 plus the square root of 3 plus 3 times the square root of 5. I've got two different radicals here. I've got some with the square root of 3 and some with the square root of 5. So on this one, if I start with the square root of 3, I've got 8 times the square root of 3, and then I've got this plus the square root of 3 where there's nothing in front of it, so I need to put the 1 there. So 8 plus 1 is 9. So 9 times the square root of 3. Then I've got my negative 2 and my positive 3 in front of the square root of 5. Negative 2 plus 3 is 1. So I can put a plus 1 in front of it. And remember, you don't have to write the 1. So it would be just fine if it said 9 times the square root of 3 plus the square root of 5. Okay, now our problem's getting more complicated. These radicals right now do not have the same number under the square root. So I am going to write my list up here, my list of perfect squares, the first few of them, and I'm going to have to simplify both of these radicals. So 4 times the square root of 54, and I've got 2 times the square root of 24, and they both need simplifying. The square root of 54, The biggest perfect square factor for 54 is 9. 9 times 6. The square root of 9 is 3. 4 times 3 is 12. So 12 times the square root of 6 is simplest radical form. 24, the biggest perfect square factor would be 4. So I can separate it into 4 times 6. The square root of 4 is 2. 2 times 2 is 4. So now take a look at what our problem looks like. I have 12 times the square root of 6 plus 4 times the square root of 6. Now they are like terms. So I can add together 12 plus 4, and I get 16 times the square root of 6 for my final answer. So I simplified each of the square roots because they were not perfect squares. And when they were in simplest radical form, they did have the same number underneath the square root. So then I could combine them together. Okay, the next one has three different radicals to simplify. And they may or may not simplify to be like terms. So here are my perfect squares. I'm going to use these in my simplifying. Okay, so the first one, 18, I can simplify into 9 times 2. 9, the square root of 9 is 3. And then the 2 that was out in front, 2 times 3 is 6. So 6 times the square root of 2. The next one, 32, simplifies into 16 times 2. The square root of 16 is 4. And the 2 that was out in front gets multiplied. So 2 times 4 is 8. So 8 times the square root of 2. So far, those two are like terms. My third one, 72, is 36 times 2. So that would be 6 times the square root of 2. There was not a number in front of that one, so it just stays 6 times the square root of 2. Now I can add all of these together. So I take the numbers in front, and I add them. That would give me 20. So my final answer is 20 times the square root of 2. So the initial problem had 3 different square roots. The square root of 18, 32, and 72. They all ended up in simplest radical form, though, with the square root of 2. So they could all be added together. Okay, our next example, 3 different square roots again. I'm going to use a different color for each one. And up at the top, okay, now the first one, 24, I can separate into 4 times 6. The square root of 4 is 2, so 2 times the square root of 6. 54 is 9 times 6. Square root of 9 is 3, so 3 times the square root of 6. And 96 is 16 times 6. The square root of 16 is 4, so 4 times the square root of 6. So again, all of my coefficient numbers ended up, all of my radicals ended up alike. So I have 6 underneath every square root, so I can take those coefficient numbers. 2 minus 3 would be negative 1, plus 4 is 3. So 3 times the square root of 6 is my final answer. Now, if these radicals, if my 3 radicals that I had in this step, they don't all have to be the same. So if they were different, I would just end up having a longer answer. I wouldn't be able to combine all of them. So like on the first, one of the first ones that we saw back here, this one, on this one right here, they were not all like radicals. They were not all like radicals. So you could end up having radicals in your answer, more than one. So they don't all have to be able to be combined. Looks like I missed a slide, so we'll do this one out of order. So maybe this one will end up giving us some that are not alike. Okay, so 4 times the square root of 12 minus 6 times the square root of 48. 12 simplifies to 4 times 3. The square root of 4 is 2. So then 4 times 2 is 8. 8 times the square root of 3. 48 is 16 times 3. So it's going to end up the same again. The square root of 16 is 4. 6 times 4 is 24. So 24 times the square root of 3. What's different about this one is that these coefficient numbers in front, 8 minus 24 is negative 16. So negative 16 times the square root of 3 is your final answer in simplest radical form. So your answer could be positive or negative on these problems. Okay, you should be able to write a summary now, answering your essential question. Make sure that you use complete sentences.